Question 7. 25 ml of 1M copper sulfate solution was put into a calorimeter and 6 grams of zinc powder was added. The temperature of the solution rose by 50.6 degrees C. Work out which reagent was in excess and then calculate the enthalpy change for the reaction, obviously using the limiting reagent. Assume that the density is 1 gram per centimetre cubed and the specific capacity is 4.18. Ignore the heat capacity of the metals. So Q equal to MC delta T. So the mass is going to be 25 as the volume of the solution used, times by 4.18 times by the temperature change, which is 50.6, and we get 5288 joules, which is equal to 5.288 kilojoules. Next, we're going to need to use the delta H is equal to minus Q over N, so we need to work out what the number of moles is. So copper sulfate, and we're using zinc. So copper is a 2+. This is also could be a 2+. In factual fact, it's a 0, but it then changes to ZnSO4 2+, and copper. Okay, so it's a redox reaction. However, it's balanced, so it's a 1-to-1. So let's work out the number of moles of each of these. So this is going to be MV over 1000. So that's 1.0 times by 25 over 1000. And this is going to be 6 divided by its MR, which is that. So this is equal to 0.025 moles. And this is equal to 0.0917. So therefore, the zinc is in excess. So therefore this is our limiting reagent, and when we now calculate our delta H value, that's what we need to use here. So it's going to be equal to the minus of 5.288 divided by 0.025, and we get 2 kilojoules per mole.